The 25% execution speed boost. Monad version 0.15.0 just reduced its block time by 25%. While the industry fixates on transaction per second headlines, the real story in 2026 is the finalized decoupling of execution from consensus. By separating the agreement on transaction order from the actual work of processing them, Monad is treating the blockchain more like a superscalar processor and less like a simple shared ledger. This architectural surgery allows the network to process transactions in the background while validators move on to the next block, breaking the sequential lock that has limited the EVM for a decade. Designing the asynchronous pipeline. In a standard Ethereum environment, execution is interleaved with consensus, meaning a node must execute every transaction in a block before it can even vote on that block's validity. Monad's asynchronous execution pipeline changes the fundamental physics of the stack by letting consensus happen first. Nodes agree on the ordering of transactions, but the actual state update is deferred to a separate process. Think of it like a kitchen that takes orders and hands them to the chef immediately, rather than waiting for the previous plate to be washed before writing down the next table's request. This allows execution to utilize the entire duration of the block interval. Breaking a state contention bottleneck. The real barrier to parallel execution is state contention, which occurs when two transactions try to modify the same storage slot simultaneously. Monad addresses this through a custom backend called MonadDB and the recent activation of MIP3, which shifted the network to a linear memory cost model. By capping memory at 8 megabytes per transaction and using optimistic parallel execution, the protocol guesses which transactions are independent and only reruns them if a conflict is identified. It is an engineering bet that the overhead of occasional re-execution is significantly cheaper than the cost of waiting for every transaction to finish one by one. The real implication. Monad's architecture represents a fundamental shift from scaling via sharding to scaling via hardware efficiency. The performance gains in the recent version 0.15.0 release and the activation of the Monadnine upgrades show that the protocol is successfully moving toward a truly asynchronous state machine. By repricing the EVM for a higher throughput environment through MIP3 and MIP4, the network is forcing a rethink of how smart contracts are designed for resource efficiency. For the broader industry, this proves that the EVM can be modernized without breaking compatibility, provided you are willing to rebuild the database layer from scratch. The real indicator of success won't be the 10,000 transactions per second peak, but whether the network maintains sub-second finality as the state size grows past the terabyte mark and faces genuine historical bloat. Watch the performance of the new transaction simulation RPC endpoint this month as a gauge for how the network handles complex, multi-state dependencies under load. Subscribe for more.